certainly these first five right here, those are the 5 ways to prove triangles are congruent. Once you've proven triangles are congruent, then you can use CPCTC to prove that parts of the triangles are congruent. So if your goal is to prove that 2 angles are congruent or 2 sides are congruent of a triangle, the first thing you do is prove that the triangles are congruent, and then you can use CPCTC to prove that the corresponding parts of those congruent triangles must also be congruent. Reminder, the 2 ways that don't work are ASS and certainly angle, angle, angle. Remember, angle, 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 the triangles are similar to each other. They're in the same proportion, but they're not actually the same. Down here is a whole bunch of ideas that you're going to use within triangle proofs. Certainly, you're going to get vertical angles, and you know vertical angles are congruent. And why? Well, you just say vertical angles. You're going to get shared sides. You're going to use a linear pair. You're going to use bisector or perpendicular or a midpoint. These things are going to pop up within the triangle proofs. If I ask you to write a triangle congruent statement, you're talking about saying something like that. And again, each letter matches and the order matters. So if you say A, B, C, and D, E, F, then you are saying that angle A and angle D, side length BC and side length EF are congruent and things like that. Hypotenuse is always the side across from the right angle, which happens to be the longest side of a right triangle. We know isosceles triangles have congruent base angles, right? Congruent sides do, in fact, lead to congruent angles, but you can look through that. All right, so here's just a whole bunch of the problems, which I would all expect to be on the test. So here I gave you a congruent statement, and then you're just matching them. So if I tell you that's true, then you know H and W, those angles are the same. You know LD and then EJ are the same. You know angle D matches with angle H. You know side length HE matches with WL, and I could even ask you to draw the 2 triangles given this congruent statement. Okay? So a lot of these next ones are suppose, meaning you know the triangles are congruent, use information about congruent triangles to then match it up. So number 1, the transformation that maps it, meaning it turns this triangle into this triangle, you can see that angle R and angle R have to match. That just stays put. That means we're pivoting there. But like if you look at K and look at M, K is going to rump over to M. It's just going to rotate that direction. Okay? So you can kind of see that that's a rotation, which really means you can match things up. We can say, well, that means that does in fact have to equal that. So set them equal to each other and then solve for X. But once you know X, you also know angle R and angle R are the same. So if that's 50 up there, then that's 50. And then you can take these three angles and add them up to 180, which is what I did here. Okay? And adding them up, and then I solve for Y. So my goal was to find X and Y, but I really used the fact that I'm matching the letters, and I also know that there's a rotation, and I know that the 3 angles in a triangle add up to 180. All right, this one, we have this triangle, and what we're going to do is we're going to see that that's a reflection, right? Take this kind of line right here and reflect it over, then you're going to end up with that same triangle. So it's a reflection, and what else do we know about this? Well, if it's a reflection, that must mean that this side length equals that side length. Well, set them equal to each other. When I do that and I solve for X, I get X equals 11. But once you know X equals 11, I can plug 11 in for any of the X values. So I guess I could change colors, and I could say, well, now I know that that angle and that angle have to be the same, so set them equal to each other. And I know X is 11, so I can put 11 in for X and get 33, and then I can get Z of 38. And then change angles one more time. I also know then that that guy and that guy are the same, but I know X is 11, so I can set those 2 equal to each other and then solve for Y. In this case, you end up with a decimal for Y, but that's okay. All right, the next couple are going to say, what additional pieces of information would you need to know in order for the triangles to be congruent? And again, you're trying to use a specific theorem, in this case, angle, angle, side. So you know that CE and OT are the same, which is why I did this. And you know that angle C and angle O are the same, which is why I made those marks. And if you want to use angle side, remember angle side is having an angle, the next angle, and the next side. Well, I need that angle to be congruent to that angle. So if you knew angle I was congruent to angle H, then you'd have angle side, angle side. All right, this one, I want to prove using side angle side. As soon as you see side angle side, you know you're going to want a side, the next angle, and the next side, which means you want the angle between the sides. And so if you look at this, you were told that that guy and that guy are the same. And then you were told this guy, that guy, and that guy were the same. Well, if you want to use side angle side, you need the angle between them, that angle, congruent to that angle. Now I have orange, blue, blue, orange, blue, blue, with a blue angle being between the two sides. Again, that's what side angle side means. Okay, so you're going to have questions like that where it says what additional piece of information. You're going to have questions where it says solve for X and Y. You're going to have a matching question. And now we have some shorter versions of proofs. We're not really writing the proof, but you kind of are in your head. So you're given these information, but then you're like, well, that side is shared by both. Are the triangles or not? Do you have enough information now to prove the triangles are congruent? Sure you do. You know that the three sides of the two triangles are identical. So we now can say side, side, side proves the triangles are congruent. You can write a congruent triangle statement, and then you can decide, well, it's really just a reflection on the line QS to go from this triangle to that triangle. All right, the next one. You have side, side angle, and side, side angle. You're like, oh, nope, not going to work. Remember, when you get that, it's not enough to prove the two triangles are congruent. So you don't have to write these because we're not even sure whether they're congruent or not. I mean, they look congruent, but we're not sure. That is not enough to prove. Now down here, I have a double, a single, and a single side, a double, a single, and a single side. Ooh, look at that. I do have the exact same angle side. So in this case, this is enough to prove the two triangles are congruent, which means I can write a congruent statement, and you can see that if you take this one and you like flip it around and you rotate it, you'll take this triangle to the other triangle. All right, this one, you are labeled there and there and there and there, but you're like, well, I know vertical angles. So, I can't even, it doesn't like me to have any more writing. Oh, those angles have to be the same because they're vertical. And I know vertical angles are congruent. So if you look at the picture now, I know I actually have side angle side, side angle side. So SAS is the theorem that proves them congruent. That's me writing the congruent statement, making sure I'm matching up certain things with certain things. So like A matches up with C and so on. And then that's a rotation. Take that guy and rump it around. You're going to get a rotation. All right, this one. Okay, so when you see that these lines are parallel, that line parallel with that line, then you know that angle and that angle are the same. And since that angle and that angle are, that side and that side are parallel, you also know that that angle and that angle are congruent. So then you have an angle side angle and the same angle side angle. You're like, look at that. Angle side angle is a way to prove triangles are congruent. I can write the congruent statement, and this is just a translation. You're just taking this first guy and just sliding it to the right. Okay, now we're going to write our proofs, which is just like the longest process. I want to prove this to be true. And if you look at that, you're trying to prove side lengths, parts of a triangle are congruent, meaning that for sure the last step is going to be that. Okay, so the first thing you have to do is you have to write out the given. You have to write out what's given, and it says AB is parallel to ED, given. C is the midpoint, given. However, what do you know about the midpoint? If C is the midpoint, doesn't that mean that that side and that side are the same, so then you say it. AC congruent to CE. How do you know that? Definition of midpoint. But now if you look at the triangle, you have, oh, sorry. I didn't actually write that. My bad. I must have got distracted. There should actually be a line in here, right in here, where it says angle A is congruent to angle E because of alternate interior. Alternate interior. And that angle B and angle D are congruent because of alternate interior. Remember, that's what this parallel part means. Remember, once you get parallel lines, you know alternate interiors are congruent. So there should have been two lines in there talking about angle A and E and angle B and D being congruent. Now when I know that, then I have angle, angle, side. Angle, side. Now the triangles are congruent because of angle, angle, side, which now means that BC is congruent to CD because of CP, CTC. Corresponding parts of congruent triangles are congruent. So write down the given, make some marks. In this case, midpoint tells you that these two sides are the same. Alternate interiors tell you these angles are the same. AAS tells you that the triangles are the same. And CP, CTC justifies why the corresponding sides are the same. All right, here. Write down the given, and there's three of them, so you just got to write them down. And then what we do know is that this angle and this angle are congruent because the lines are parallel. But then you have boom, 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 boom. The two triangles are now congruent because of side, angle, side. So in this question, we were proving triangles are congruent. In this question, we are actually trying to prove that the two parts of triangles were congruent. Here, our last line is CP, CTC because we are trying to prove that the two parts were the same. So prove the triangles are the same first, then you can claim the parts are the same. Here, all we really wanted to do was claim that the triangles were congruent. So we don't need CPTCC in this question. We can just stop right there. All right. This one, again, we want to create a triangle congruent statement. So we're not going to need CPTCC. We're just going to need angle, angle, side, or side, 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 and stuff like that. So write down the givens, no big deal. And then we know that KM is congruent to KM, meaning it's just a shared side, right? And that's what you can say. You can also say reflexive, but shared side is fine. And then we know that this angle and this angle are the same. Why do we know that? That's the definition of a bisector. And now we have angle, angle, side, angle, angle, side. So we have angle, angle, side is the way we can prove that the two triangles are congruent. Okay, so write down the given, shared side, definition of bisector. Now we have all these labels, and now we can prove the triangles are congruent because we've shown that we have a right angle, we have a little angle, and we have a shared side. And we have the exact same combo on the bottom. This situation ends up being a side-side angle, and we know that side-side angle or angle side-side is not enough to prove. Not enough. So we can just kind of skip that one. 15, okay. Now we want to prove that something is a midpoint. So we're going to end up going one step even further than CP, CTC. So write down the given. NV is congruent to NV, this side right here, because it's a shared side. And now if you look at the two triangles, we have side, angle, side, side, angle, side. So the two triangles are congruent. Why? Side, angle, side. But doesn't that mean that AV is congruent to YV? Why? Corresponding parts of congruent triangles are congruent. But if AV is actually congruent to YV, doesn't that mean that V has to be in the midpoint? And so our last sentence is always what we want to prove. V is the midpoint. How do we know that? Definition of midpoint. I just proved to you that AV is congruent to VY. That proves that V is, in fact, the midpoint. So I think this is probably our only example where the last step isn't CP, CTC. All right, this one you can kind of go through, but it's all about matching, right? XYZ, PQR. You can write out like a matching marks just to make sure you're like, all right, this angle and this angle are the same. This top angle and this top angle are the same, stuff like that. But it turns out that this one's true. And this last one I actually wouldn't worry about. I'm not going to put something that difficult on the test, but essentially you just you are using the fact that you know isosceles triangles. Let's erase that. Isosceles triangles, if that is the same as that, then this angle down here, this angle down here and this angle over here, they're actually the same. And so that's really just that process I use, but I wouldn't worry about that. I would, let's skip that one and really just make sure that we understand the other ones. So a whole bunch of triangle proofs, including CPTCC, shared sides, midpoints, bisectors, parallel lines. Again, all the things that I said up here, all these ideas, they all pop up somewhere in these triangle proofs. And so make sure you really review the vocab. But I would say this is pretty similar to the test, and hopefully this video has helped out.